This section is called Working on a Sharded Cluster. So let's take a look at what I've set up. This is all on localhost, but I've got 3 shards, shard01, shard02, shard03. Each of these shards has a primary, a secondary, and an arbiter. I've only got 1 config server up. In production, you'd want 3. I've got a single MongoS router, which is able to route my queries to the 3 of these guys, and I'm connecting with my Mongo shell, which you can think of as the application. Let's take a look at the queries. Now, in many, or even most ways, this is going to be just like using a MongoD. But in practice, there are some differences that we're going to want to explore. Now, my example collection is already sharded. Let's take a look at what the documents look like. As you can see, it's got an A, B, C, D, E, and F field, plus an underscore ID. Most of these are 1 here, but they run the gamut between 1 and 10 on each field. As you can see, there are just under 1 million documents. I've dropped a few so that a couple of queries that I'm going to do only return 1 document each, just to keep things simple. So you can see that the find query works normal. And if I try to insert this document, it works great. No surprises there. I might think that this insert is going to work fine, but when I try it, oh, that didn't work at all. So what's the problem? Oh, my document doesn't contain the shard key. It needs to have a B, a C, and a D. So my inserts are now going to fail if I don't include the shard key on the document. Let's see what indexes we've got. Okay, this is pretty straightforward. I've got my underscore ID index. I also have the shard key that I've set up. Can I create more? Well, let's see. Whoa, that looks different. Let's scroll up and figure out what happened. Okay, what happened was that the indexes got created on each shard. Shard01, shard02, shard03. And if I actually look at what happened, the primary and the secondary each built the index. The arbiter didn't need to build the index because it's an arbiter. It doesn't contain any data. And I can see how many indexes each of them has before and after. Great, so all of them now have the index. This will make queries that hit any of these shards much faster as normal. Now my best index, and the one that I should use the most, is on the shard key. And that lets me hit only some servers. It's called a targeted query. Other indexes, though, are still a big improvement over collection scans. Let's create an explainable object so we can see what's happening when we do a query. We'll be wanting to look at the execution stats here. Let's look for a document just using the shard key. Sorry about the fact that a lot of the output is going to be wrapped. But as we can see, 1 document was returned, and when we look down, we can see things for each shard. In this case, shard02 had the document, and returned was 1, and it was able to use an index scan. In this case, it was using my shard key index. And when I scroll down, I can see that that's the only shard that was hit. So that was a targeted query. Let's take a look at a query that isn't targeted. We call these scatter-gather queries. Now note that this is going to use the index that I just created. I think that was E, F, A, but order doesn't matter in the query. It matters in the index. So once again, when I look at my execution stats, only 1 document was returned. However, when I start looking at my different shards and see what happens, oh, here's shard01. Now that didn't have any documents, and returned was 0, but it still got queried. Shard02, and returned was 1. This was the one with my document. And shard03, and returned was 0. So shards 1 and 3 were asked even though they didn't have the document. I also want to point out, this is wrapped, but shard02 did use an index scan to find the 1 document that it returned. So that's a scatter-gather query. That's a query where every single shard has to be hit. And again, that happens because we didn't use the shard key. So let's talk about targeted versus scatter-gather queries. Even your scatter-gather queries should still use an index, but they can't use the shard key. So when that query goes out, you have to hit all your shards because you have no idea where the document is. Could be in any chunk. And there's going to be communication overhead for this. Now I've only got 3 shards here and it's all on localhost, so the communication overhead is negligible. If I had 10 shards, again, not a big deal. But if I had 1,000 shards, well, now we're talking about some significant communications overhead. This might still be acceptable for rare queries. I mean, if I did it once an hour, no big deal. But if I tried to do it 10 times a second, I could really slow down my system. And especially that MongoS that I was using, which has to send the queries out and then get the responses. So targeted queries, which use the shard key, are great, but scatter-gather queries may not give you the same level of performance in large clusters. By the way, a query doesn't have to use the entire shard key to still be targeted. Let's do an example. Now remember, my shard key is B1, C1, D1. Here we're looking for B6, and C can be 3, 4, or 7. D we're not even bothering with. So we've got a whole range of documents. When I look at my execution stats, I got 29,970 documents back, took 76 milliseconds. And when I look at the shards, well, this was on shard 03, and when I scroll down, I can see that was it. That was the only shard that was hit, so it was still a targeted query. If I had queried in a range that hit 2 chunks, I probably would have gotten 2 of my shards that were hit by the query. So a targeted query may not isolate it down to 1, but it does much, much better than definitely hitting every single possible shard. Okay, to review, we've seen how find, insert, and create indexes work on a sharded cluster. We've seen how explain includes data for each shard when we do our queries. And we've seen that targeted queries, which use the shard key, have less communications overhead than scatter-gather queries, which don't. Okay, time for a quiz.